I've got a bunch more identities up here on the board, 12 of them, because there are 6 trig functions, and each of them has a cofunction identity and a periodic identity. Okay, I want to just talk through what these are, and then we're going to prove a couple of them. Before I do that, though, I just want to point out these are all on page 584 of your text. So you may find it easier. I hope you are taking notes as you're watching these videos, but you may find it easier to simply copy those out of the textbook rather than try to copy them down from the screen. Okay, now the cofunction identities, I remember that they're true by thinking about the specific case that theta is an acute angle so that I can use right triangle trigonometry. So if this angle was theta, and I'm measuring in radians, this is 90 degrees, which in radians would be pi over 2. This has to be the complement of theta. So this angle right here would be pi over 2 minus theta. It would be the complement. They have to add up to 90 degrees, or in radians, they have to add up to pi over 2. Okay, so complementary angles are the two acute angles that would occur in the same right triangle. Okay, so if I were to calculate, let's just look at this first one, cosine of theta, that would be this side here. Let me just label them A, B, and C. Okay, A would be adjacent to theta over the hypotenuse, so A over C. But here's pi over 2 minus theta, that's the complementary angle. Sine of that would be the opposite side, which is also A over C. Okay, and in fact, that's where the name cosine comes from. Cosine of an angle is sine of the angle's complement. Same thing works for these other names. Cotangent of an angle is tangent of the complement. Cosecant of an angle is secant of the complement. Okay, so that's how I actually remember that these are true. However, there's nothing that says that theta here has to represent an acute angle. These identities are true for any angle. So theta could be negative 27 pi, okay? And there's no way I could put negative 27 pi in a right triangle. But these identities would still hold. What we're going to do in a moment is we're going to use the difference formulas to try to prove that. Okay. These other identities are things that we know from the graphs of our trig functions. We know that they're all periodic, that sine, cosine, secant, and cosecant have a period of 2 pi, and tangent and cotangent have a period of pi. Okay. So what that means is if I take theta and I add 2 pi to it, oh, that's giving me a coterminal angle. Sine of that is going to be the same as sine of theta. Okay. There I can think of it as just, it's a coterminal angle, so it's going to have the same sign. I could also think of it, if I look in terms of the graph of sine, if I'm here, the next time I'm here, that's a distance of 2 pi apart. That's 1 period apart. So if I'm at a particular place and I add 1 copy of the period, I'm going to have an angle that has the same sine, or cosine, or secant, or cosecant. With tangent and cotangent, because the period is pi, if I add pi to an angle, I'm not going to get something that's coterminal, because I haven't gone a full revolution around, but I am going to get something that has exactly the same tangent or the same cotangent. If I'm looking on the graph of tangent, if I'm here and I add pi, that's going to take me to the same place in the next period of the tangent graph. Okay, so that's what all of these identities here say, and we could prove these, of course, using the sum formula. Okay, so I'm just going to pick one. Let's pick this first one here. Let's do the cosine one, and let's do cotangent. Okay. So, in a moment, I'm going to have you pause the video and try to prove these two identities, remembering that when we're proving an identity, we can only work with one side at a time, okay? And I'm going to point out, I didn't give you a sum formula for cotangent, but I did give you a sum formula for tangent. And cotangent is just the reciprocal of tangent. So you can combine your reciprocal identity and your sum formula for tangent, and then you'll have a sum formula for cotangent as well. Okay. Same thing would work for secant and cosecant. the reciprocals of the sum formulas for sine and cosine are going to give you the sum formulas for cosecant and secant. Okay, so go ahead and pause the video, try and prove those two identities. So I've cleaned up the board a little bit. I've just left up the two that we're going to try to prove. So I'm proving this identity. Here's my left-hand side. I want to show that it's equal to that right-hand side. And remember, I'm only allowed to work with one side at a time. I want to start with the more complicated side. So I'm going to say my right-hand side, that's equal to sine of pi over 2 minus theta. Okay. I do need to explicitly copy that. I can't use this version because in my proof, I have to be able to justify every equal sign, and that one is not yet justified. Okay, so it looks like I'm going to be using the difference formula for sine. So that's just the sum formula, except instead of having the plus sign in between the terms, it's going to be a minus sign. So this is going to be sine of pi over 2 times cosine of theta minus cosine of pi over 2 times sine of theta. Okay, now that's a very specific angle. I know that sine of pi over 2 is 1, so I'm getting 1 times cosine of theta, minus cosine of pi over 2, well that's 0, so I'm getting 0 times sine theta. That kills off this term. I'm getting 1 copy of cosine theta. I'm getting cosine of theta, which is the left-hand side. So there we were able to prove this identity, and the other 5 cofunction identities are very, very similar. Okay, so let's try working with this one. Here's my left-hand side, and here's the right-hand side. Okay, this side looks more complicated, so let's start with that. So the left-hand side was cotangent of theta plus pi. I'm sorry, cotangent, not cosine. And I'm just going to say that's 1 over tangent of theta plus pi, so that then I can use my sum formula for tangent. Okay, so that's going to equal 1 over, this is going to be tangent of theta plus tangent of pi over 1 minus tangent of theta times tangent of pi. Okay, that was my sum formula for tangent. Now, if it's 1 over this fraction, I can go ahead and just take the reciprocal of that fraction. So I can say, rather than it being 1 over that fraction, let's just take that reciprocal by writing this as 1 minus tangent of theta times tangent of pi over tangent of theta plus tangent of pi. And if you felt comfortable going right to that, just taking right off the bat the reciprocal of the sum formula for tangent, that would be fine. I'm just showing a little bit of work for how I got there. All right, let's figure this out now. What is tangent of pi? Okay, well, if I look at my unit circle, pi would be here. At this point, -1, 0. Tangent is the capital Y over the capital X value, so it's just 0. Oh, okay, so this is 1 minus tangent of theta times 0 over tangent of theta plus 0. Well, that's going to just be, that kills off this term, so it's just 1 over tangent of theta. I've completely run out of board space, so I'm going to erase this one and move over to the left side of the board. Evaluating that, I just get 1 over tangent of theta, but by my reciprocal identity, that's cotangent of theta, and that was my right-hand side. So we were able to prove this identity as well. And again, the other 5 periodic identities are very similar. I'll just point out, the version given in the book has us adding 1 copy of the period. If I wanted to, I could replace that with any multiple of pi. Okay. So I could say cotangent of theta plus n times pi, where n is an integer, would equal cotangent of theta. That would work out because at any multiple of pi, tangent is going to be 0. So I'm going to simplify it the same way. Okay.